Hello, students. Welcome to Trunkie Academy. I'm Dr. Pallavi Kulkarni, your chemistry teacher. And yes, so we have started since Monday. We have started about the chapter metals and non-metals. And today we are going to discuss the next topic from the same chapter. Yes, we have started with the metals and non-metals. Metals and non-metals. In the last class we have discussed about the physical properties of metal. Today we are going to start the chemical properties of metals and non-metal. Chemical properties of metals and non-metals. Let's have a quick recap of previous session. So in the last class we have discussed the physical properties of metals and non-metals. The properties like hardness. I will list of the properties only. So first property was hardness, then luster, then malleability, then ductility, sonority, then high density, then high melting and boiling points, high melting and boiling points, then conductance of heat and electricity. Conductance of heat and electricity. So these properties we have discussed in the yesterday's session. Okay, yes. Now in today's class we are going to start with the chemical properties. So first of all, let me just tell you the general chemical properties of these metals and non-metals, and then we are going to discuss the in detail the chemical properties of metals and non-metals one by one. Okay, so first chemical property is metals lose, or there is another word for that, donate 1, 2 or 3 valence electron. Valence electrons are the outermost electrons. Electron present in the outermost, that is valence shell. Okay, whereas non-metals gain the electrons. Okay, we'll do one thing. Yeah, just let me list first of all of them. Second, therefore metals form after losing the electron, metal will get the positive charge, right? Therefore metals form positively charged ions, and positively charged ions are called as cations, and non-metals form negatively charged ions. Negatively charged ions are called as anions. Negatively charged ions are called as anions, right? Okay, yes. Then next property, metals form basic oxides with oxygen. And non-metals forms acidic oxides. Non-metal forms acidic oxides. With oxygen, right? And fourth property, metals form metals as well as non-metals. React with acids. React with acids to produce salt and hydrogen gas. So these are the properties of metals and non-metals in general. Okay. Now you can just take a screenshot of this page, chemical properties in general. Take a screenshot. I hope you have taken a screenshot. Now let us start actual chemical reactions of metals and non-metal. So let us start first chemical reaction of metal, and that is nothing but reaction with oxygen. Chemical reaction with air. In air, metals react with, or non-metals react with oxygen. Right? We are going to see what will happen to metals when they are burned in air. Okay, what we are going to discuss here. What happens when metals are burned in air. When metals are burned in air, that part we are going to see. So as I have already told you, the metal will combine with oxygen and it will produce the metal oxide. Right? This reaction already I have told you. Let us see some examples one by one. So first example is of copper. When it reacts with O2, it gives you CuO. Okay. Now here you can see the reaction is not balanced. Yes, here you can see the reaction is not balanced. So for balancing, I will put 2 here and 2 here, right? So when copper solid reacts with oxygen gas, we get copper oxide, which is also a solid, right? Yes, so here this is the copper metal in CuO, copper oxide. If we find the oxidation state of Cu, right, how we can do that, I have explained this thing to already. Let us assume oxidation number of copper is X, and we know oxidation number of oxygen is equal to -2. Molecule as a whole should be electrically neutral. Therefore, there is only one copper, so 1 into X, plus there is only one oxygen, so 1 into -2. The sum should be equal to 0. So X minus 2 is equal to 0. X will be equal to 2. That means oxidation state of copper in CuO is +2, right? Therefore the name will be copper. Inside the bracket we can put oxidation number in Roman 2 oxide, right? What is the name of this oxide? Copper 2 oxide, right? Yes, so what we are getting? Oxide we are getting from this reaction, right? Take a screenshot of this page. Okay, some more examples we can have. Next example is of aluminium. So this is a black colored oxide. Black oxide. Next example for aluminium. Aluminium combines with oxygen. It gives us Al2O3. For balancing, I'll put 2 here, 3 here and 4 here. Okay, so aluminium solid reacts with oxygen gas to give you aluminium oxide. So this is aluminium, gives you aluminium oxide. Okay, yes, now here this yes, so here this example which I have given here, this is a basic oxide. Okay, this is a basic oxide, but this example aluminum oxide is the amphoteric oxide. Okay, it is amphoteric oxide. I'll explain why this is amphoteric oxide later on. Before that, let us first of all write down all the reaction. Next reaction is with the sodium metal. Sodium metal, when it combines with oxygen gas, it gives you sodium oxide, Na2O. Okay, Na2O solid. For balancing, I'll put 2 here, 2 here. Okay, so Na is nothing but sodium. It gives you sodium oxide. Okay, sodium oxide is also a basic oxide. I will explain why these oxides are acidic or basic later on. Let us first of all write down all the reaction. Then next is the potassium. Sodium and potassium give the same reaction. So K2O is nothing but the potassium oxide. It is also a basic oxide. Okay, yes, so here I have written 3 examples, that is 4 examples, not 3: copper oxide, aluminum oxide and sodium oxide. Now you guys can do one thing. First of all, take the screenshot of all these 4 reactions. Okay, I hope you have taken a screenshot. Now let me explain what is the meaning of this basic oxide and amphoteric oxide. Okay, so just usually I am saying metal oxides are basic in nature. Usually I am saying, okay. Non-metal oxides are acidic in nature. Okay, but there are exceptions. Some of them are. Some oxides are alkaline. Neutral oxides and amphoteric oxides. Okay, yes. So neutral means neutral oxides, neither acidic nor basic, right? Whereas amphoteric oxide means amphoteric oxides shows both properties. Both properties means what? Acidic as well as basic. Okay, yes. So these are nothing but the oxides. Now let us see examples which I have given to you here. So first of all, let us write down about CuO, right? Copper oxide. Can you see this reaction? Okay, now copper oxide is a solid substance. When I dissolve it in water, okay, what I will get? I will get CuOH twice. Okay, now this CuOH twice, which is called as copper hydroxide. Okay, this copper hydroxide can furnish OH minus ions. Okay, can you see OH group is present in it that can be furnished in the water. Therefore, that means this copper oxide is OH minus donor and hence basic oxide. Hence basic in nature. Similarly, we can write down for the sodium oxide also. Na2O, when it is dissolved in water, we get twice NaOH. Okay, now this twice NaOH, that is sodium hydroxide. We know sodium hydroxide is the popular example of an alkali. Okay, it is an alkali and all alkali are basic in nature, right? Similarly, we can write down for the potassium oxide exactly same like sodium. K2O when dissolved in water gives us 2KOH. Now this is the potassium hydroxide, and potassium hydroxide is also an alkali, right? Alkali means water soluble bases, right? That's what it is, basic in nature, right? Okay, now these three were examples of basic oxide, but I have told you aluminum oxide Al2O3 is the amphoteric oxide, right? Why it is amphoteric oxide? Aluminum oxide Al2O3. Okay, this is an example of amphoteric oxide. Amphoteric oxide means it will react with both acid as well as base, right? So this is the amphoteric oxide. That means we are going to write down the reaction of this aluminum oxide with acid as well as base, right? So let us take Al2O3. Let us treat it with HCl. Okay, aluminum oxide when treated with HCl, HCl is a strong acid, right? Amphoteric oxide has a specific nature. When they are treated with the strong acid, they will act as a base. Okay, and when they are treated with the strong bases, they will act as acid, exactly according to the nature. So acid plus base, this is the neutralization reaction. We will get AlCl3 plus H2O, salt plus water, right? AlCl3 is a salt, aluminum chloride. Okay, aluminum chloride is the salt obtained plus water. This is also a neutralization reaction, right? Acid react with base to give salt and water. Okay, let us balance this equation. So for the balancing, so let us see. So elements, number of atoms on left hand side, number of atoms on right hand side. Okay, let us start with aluminum. On the left hand side it is 2, right hand side 1. Then next is oxygen, left hand side 3, right hand side only 1. Then next is hydrogen, left hand side 1, right hand side 2. Then last is chlorine, left hand side 1, right hand side 3, right? So first of all we are going to balance the the aluminum atoms, right? Okay, now aluminum atoms on left hand side it is 2, right hand side is 1, therefore we will multiply this right hand side by 2. That means we are going to multiply this by 2, AlCl3. So when we are multiplying AlCl3 by 2, not only aluminum but chlorine is also changed. Chlorine previously it was 3, now it is changed to 6, right? So now it is time to balance the chlorine atom. So chlorine atom on left hand side it is only 1, so I will multiply it by 6. So left hand side chlorine is present in HCl. By doing so, not only chlorine but hydrogen is also changed. So hydrogen previously was 1, now it is equal to 6, right? Therefore I will balance the hydrogen on the right hand side. Okay, right hand side is 2, I will multiply it by 3, so it will become 6. Hydrogen is present in water. So by doing so, not only hydrogen but oxygen has also changed. Previously oxygen was 1, now it is changed to 3, and now oxygen is also balanced. So this is a balanced equation, right? Al2O3 reacts with 6 HCl gives you 2AlCl3 plus 3H2. So in this reaction Al2O3 is acting as what? A base, right? Because we treated it with the strong acid. Now let us see what will happen if we treat it with the strong base. Okay, so again I will take Al2O3, I will treat it with the strong base NaOH, right? NaOH is a strong base, right? Yes, so here NaOH, sodium hydroxide, is a strong base. So when treated with the strong base, Al2O3 will act as the acid, opposite, right? Because it is amphoteric, it does not have any its own characteristic feature. It acts or it behaves according to the environment, right? NaOH is a strong base, therefore Al2O3 will act as an acid. So this is also acid base reaction. Here also we will get a salt and water. The formula for salt is NaAlO2. Okay, name of this salt is sodium aluminate. Sodium aluminate, this is the name of the salt. Okay, and plus water, right? Okay, now let us balance this reaction also. Okay, for that purpose let us see the elements. Present on left hand side, present on right hand side, right? Let us start with aluminum. Aluminum on left hand side is 2, right hand side is 1. Next is oxygen. Oxygen on left hand side is 4, right hand side is 2 plus 1, 3. Then next is the sodium, on left hand side is 1, right hand side is also 1, right? Then next is the hydrogen, on left hand side is 1, right hand side is 2, right? So first of all, to balance the I'll start by balancing the hydrogen atoms. Okay, yes, or let us balance with the aluminum atom also. So aluminum atom on left hand side is 2, right hand side is 1. So I'll multiply the right hand side by 2. So it will become 2Na2L NaLO2. By doing so, not only aluminium but sodium and oxygen has also changed. Sodium previously was 1 on the right hand side, now changed to 2, and oxygen previously on right hand side was 3, but now it has changed to 2 into 2, 4 plus 1, that is 5, right? So it has changed to 5. Okay, yes. Therefore now it is time to balance the sodium on the left hand side, right? Sodium on the left hand side was 1, now we have to multiply it by 2, so it will become equal to 2. So I have multiplied this by 2, right? Okay, now by doing so, not only sodium but oxygen and hydrogen has also changed. Oxygen previously it was 4 on the left hand side, now it has changed to 3 plus 2, that is 5. So by doing so, oxygen is also balanced. Hydrogen previously was 1 on the left hand side, but now changed to 2. Now hydrogen is also balanced. So by only putting 2 for sodium hydroxide and sodium aluminate, this reaction is balanced. Now from these two reactions, it is proven that sodium aluminum oxide is an amphoteric oxide. Why? Because it acts as acid as well as base. When treated with strong acid, it acts as an base. When treated with the strong base, it acts as an acid. Take a screenshot of this, all these pages, starting with this. Yes, first of all, take a screenshot of this. You can take a screenshot of this page also. I hope you have taken a screenshot. Now this property of aluminium to get converted to aluminum oxide very easily, this is having one application. Okay, this property of an aluminium has one application, and what is that application? That application is called as anodizing. Okay, let me explain the process of anodizing. So what is anodizing? It is the process of forming a thick oxide layer of aluminium. Okay, thick oxide layer of aluminium. Okay, aluminium converted into oxide very easily. Therefore, this is converted into aluminum oxide very easily. This layer of oxide will prevent the further oxidation of aluminum metal inside. What do I mean by that? I'll tell you. Let us assume that this is the aluminum vessel. Okay, this is the aluminum vessel. Now these are the aluminum atoms, right? These are the aluminum atoms. Okay, now I am showing the aluminum atoms only of this on the surface area, right? Assume that these are the surface area, Okay, what is this? This is nothing but the aluminum atoms. Okay, now these aluminum atoms are exposed to the air. Once they are exposed to the air, they get converted into aluminum oxide, right? They get converted into aluminum oxide, Al2O3, very easily, right? So I'll do that. I'll convert these layers into aluminum oxide, right? So there will be a coating, there will be a layer of aluminum oxide on the surface of this aluminum vessel, aluminum utensil, aluminum material, right? Okay, so this is the layer of aluminum oxide above it. Okay, now due to which what will happen, it will be having a coating of aluminum oxide, due to which what will happen, the aluminum atoms which are below this aluminum oxide layer inside the material, right? These are the aluminum atoms, right? So these aluminum atoms, they will not be exposed to the oxygen, right? Because having the coating of the aluminum oxide on them, as they will not be exposed to the oxygen, they will not get corroded, they will not undergo the oxidation. Therefore further corrosion will be prevented, right? Further corrosion will be prevented and the vessel will remain intact as it is for longer time. This process is called as anodizing. Okay, now this layer of oxide can be made more and more thicker to get a better protection, right? So for that purpose, we are the anodizing is nothing but the electrolysis process. Okay, this is nothing but the electrolysis process. So in this what is done, we are taking, I'll write it down here. So what is done here, we are taking clean aluminum article, clean, that is which is not converted to oxide, clean aluminum article. Okay, that is clean aluminum article is made, just a minute, is made cathode and H2SO4 sulfuric acid is made anode, right? At anode oxidation takes place, therefore O2 gas evolved further oxidizes the clean aluminum article, the clean aluminum article and avoids further corrosion. Corrosion is nothing but the oxidation, right? And this process is called as anodizing. Now this layer of aluminum oxide which we have created here, this layer of aluminum oxide can be painted or can be dyed with beautiful colors to give the beautiful finish to the aluminum articles, right? So this is the application of anodizing. Okay, take a screenshot of this page fast. I hope you have taken a screenshot. So today we will stop here only. In the next class we are going to see the next reaction of metals and non-metals. So before ending the class, let me just tell you about the DPP, daily practice problems. So this is a teacher's portal. Similar will be the student portal. You have to go to resources, then on the left hand side you can see writing material, wherein you will see the DPP, daily practice problem. You can download it, you can solve these questions, write down the solutions on your notebook and take a picture of those solutions and upload it on your portal. So teacher will be able to see that and teacher will evaluate and let you know the suggestions and corrections wherever required. Okay, so that's all for today. Thank you so much for your precious time, students, and all the best to you. Take care. Bye.